Hi everyone, welcome to this maths tutorial. In today's video, we'll solve the value x from the given question. The question says 9 to the power of x, which is equal to 4 times 3 to the power of x minus 3. By saying solution. Again, we can start from the given equation. The equation is 9 to the power of x, which is equal to 4 times 3 to the power of x minus 3. So 4 is taken as the constant multiple of what? 3 to the power of x. Then again minus 3. Now we must apply the rules of the same base on both sides of the equation. That means 9 to the power of x and 3 to the power of x must have what? The same base. So 3 is smaller than 9, but 3 is what? The least prime number than 9. So 9 must be expressed in terms of 3. So we know that 9 is written as 3 times 3, which is expressed as 3 to the power of 9 with 3 to the power of 2 the whole power of x, which is equal to 4 in brackets 3 to the power of x minus 3. And also again we apply a to the power of m the whole power of n is always expressed as a to the power of m times n. So because of this, 3 to the power of 3 to the power of 2 the whole power in brackets x is written as, yes guys, this is expressed as 3 to the power of 2 times x is twice of x, which is equal to 4 into 3 to the power of x minus 3. Now this can be again expressed as, this is also rewritten as 3 to the power of x the whole power of 2, which is equal to 4 into 3 to the power of x minus 3. Now again this question is expressed as 3 to the power of x the whole power of 2. We take 4 into 3 to the power of x minus 3 to the left of the equation. We get 4 minus 3 to the power of x. 3 is positive, so yes, positive, which is equal to 0. Now we must substitute 3. Here is 3 to the power of x the whole square. Now let a be a, which is equal to 3 to the power of x. Now we substitute a from this equation. We get a to the a square minus, here is 4 times a plus 3, which is equal to 0. Why? Because a is what? 3 to the here is a, here is again a. Now this equation looks like a square minus 4a plus 3, which is equal to 0. This equation is expressed with quadratic form. That means ax squared plus bx plus c, which is equal to 0 form. So now we must apply the rules of what? We must apply the rules to factorize any quadratic equation. That means find two numbers, their product is 3, and also what? Their sum is minus 4. The numbers must be the product which gives us 3 are, yes, minus 1 times 3. Minus 1 times minus 3. We get what? 3. And also their sum becomes negative 4. That means what? Negative 1 plus minus 3, which is equal to negative 1 minus 3. We get what? We get negative 4. 3. Then we can substitute from here a square minus a minus 3a plus 3, which is equal to 0. Then again we can group this a square minus a with, and also 3a plus 3. So from here we get a in bracket a minus 1, and here again minus 3 is taken as a common factor, then a minus 1, which is equal to 0. Now again we have what? The common the common factor a minus 1 from here, and also a minus 1 from here. So now we take a minus 1 times here we have a, here minus a minus 3, which is equal to 0. So the value of a becomes a has two solutions. That means a minus 1, which is equal to 0, or a minus 3, which is equal to 0. So the first solution of a is 1, and also, or the second solution of a is, yes, 3. Now we apply back substitution of the starting equation. That means we start from here by saying a, which is equal to 3 to the power of x. So by substituting the value of a, we can get each individual values of yes, x. Let's the first solution of a is what? 1. So a, when a which is equal to 1, 3 to the power of x, which is equal to 1. So 3 to the power of x, which is equal to 1, means 3 to the power of x is an exponential term. So when we get what? 1 on the right of the equation, that means 3 to the power of x, which is equal to 3 to the power of what? 0. So that means what? 1 is equal to 3 to the power of 0. So the value of x becomes what? 1. Yeah. Okay. The first solution of a is 1. What about the second solution? The second solution becomes, we can find the second solution of x from here. So let's say a, when a which is equal to 2, then 3 to the power of x, which is equal to what? Yes? No. When a which is equal to 3, sorry, for my mistake, 3 to the power of x, which is equal to 3. That means 3 to the power of x, 3 can be expressed as 1. 3 to the power of 1. So here the value of x, oh, sorry. This from here, 3 to the power of x, which is equal to 3 to the power of 0 means, please take x, which is equal to 0. So the first solution of x is 0 here. And also again from here, 3 to the power of x, which is equal to 3 to the power of 1 means x, which is equal to 1. This is the second solution of x. So x, which is equal to 1 is the second solution. So those two solutions are applicable on what? 9 to the power of x, which is equal to 4 times 3 to the power of x minus 3 are what? Satisfied. So x becomes 0, or x, which is equal to 1. Let's say, for example, we can substitute 0 from this. 9 to the power of 0 becomes 1. We can get 1 here. When we substitute 3 to the power of x, so the value of x is 0. 3. So 3 to the power of 0 is 1. 4 times 1 is 4. 4 minus 3 is what? 1. When we substitute x, which is equal to 0. So the solutions are x, which is equal to 1, or x, which is equal to 0, are satisfied the given equation.